All right. Yes, so I work at Basho. I'm like a senior engineer or something. And I also developed for Basho a library called Logger, which is intended to, basically make logging less painful. But, logging is a really boring topic. Nobody really cares about logging. But it should work when you need it, right? It shouldn't be one of those things that is always an afterthought. You should do it right once, and then you never have to worry about it again. The other thing about logging is that if you ship an application to a customer, the logs are then a customer-facing part of your application. They're going to look at the logs, and if your logs are terrible, they're not going to be too happy with you. And obviously, it should perform well and behave well. So let's take a look at what the default AirLogger does. It has 3 log levels. Well, it sort of has 3 because you get info, warning, and error. But warnings actually default to being error messages. You can set where a warning maps to with the plus capital W flag to the VM, but it defaults so that you really only have 2 error levels, warning or info and error. Warning doesn't really exist. It uses a gen event because everybody uses gen events for logging. And processes notify the error logger that they have an error using the asynchronous gen event notify call. There's also a synchronous call called sync notify, but error logger uses asynchronous notification. And if you want to do size rotation of your log files, there's a special handler called logmfh.erl, and you have to configure that one separately in your app config. Because by default, the default file handler does not include any rotation at all. So what are some problems with this? Not having any back pressure in the system is sort of dangerous. You can just fire log messages as fast as you want, and you're sort of like, well, it's somebody else's problem now. I don't care. But in reality, everything lives on the same VM. You can't keep offloading responsibility forever. You eventually have to pay for your excesses. You can't configure AirLogger at runtime at all. It was configured by the app config, and then you're just go until the VM stops, and then you can reconfigure it when the VM boots up again. Another interesting choice that it makes is that it passes the format string and the arguments into the gen event, and then does a format per handler. Now that's interesting if you want to do something like log a big term, or you're doing the format possibly 2 times, possibly more, depending on how many handlers you have installed. And also, if the term that you're formatting is really large, you're copying that whole term into the other process's mailbox, which can be bad. And rotation in AirLogger is really awesome. It'll give you these 5 files, 1, 2, 3, 4, 5, and an index file. And we had I've seen customers be like, well, I have 5 log files, but which is the latest one? Is it 1? Is it 5? And the answer is, it depends. Maybe the latest index is in the index file. Maybe the latest file name is in the index file. Well, we can't the index file, and it's Control-E. Well, that's not very helpful. So you end up having to either look at the size of the file or the timestamp on the file to figure it out, or realize that the index file actually contains the latest file name as a decimal, not an ASCII value. So you have to use like hex dump from the shell to figure out what the hell your latest file is. I mean, it works, but it's really not very intuitive, and it's not like any other logging I've ever experienced. So it confuses the hell out of people who are used to regular UNIX logging. So the other cool thing about logging, or file rotation, is that, let's say you are filling up your drive, and your file rotation, your log files are 10 megabytes, and you're keeping 10 of them. And so that's 100 megabytes right there. But you realize, oh crap, I only have 6 megabytes left on disk, and I don't want to fill up wherever I'm logging to because it'll start other stuff crashing. So let's just delete the log file. Well, that would work, except that Erlang never checks that the file handle it's writing to still references an existing file. So if, in Unix, if you open a file, delete the file handle, but keep that file, you can keep writing into that file handle until you close that file, and then the disk will reclaim it. But if you don't ever close that file handle, that file never actually removes, so you are still consuming space on the drive. Now, a lot of daemons support the hup signal, like Apache. If you want to rotate Apache's logs, you just kill -hup it, and it will reopen all of its log files. You can't do that in Erlang, so you're sort of in big trouble here. If you have a problem where your logs are getting too big, there's not really anything you can do other than like kill AirLogger or remove the handler, which is sort of a lot of people who are just running an Erlang service, not Erlang developers, aren't going to know how to do all this crazy stuff. It shouldn't be this hard. But it gets even better. OTP errors, when a gen server, gen FSM, or whatever crashes, it includes the entire process state as well as the last message received. So if you're doing something with a lot of data in a process, like transcoding a video or building some enormous list because you're doing email processing, well, congratulations, you've just copied that entire amount of data into the AirLogger's mailbox. And if that's a lot of data, or if you have a lot of big things that are crashing, that becomes very large very fast. Even better, AirLogger tries to print whatever you tell it. So if you had a 10 megabyte binary in your state, copying it isn't going to be too bad because it's an off-heap binary. But AirLogger will happily try to print the entire 10 megabytes to your log file and to your console. In practice, this will never actually happen because you'll out of memory the node long before it even gets close to being able to do this. But it tries really hard to do that for you, which is pretty good. So AirLogger is basically just a time bomb waiting to explode in your node. If you Google for it, like the internet is full of people struggling with AirLogger, crashing their nodes. And there's nothing they can do about it because AirLogger is part of OTP. So if you use OTP, you're sort of on the hook for AirLogger, unless you uninstall all the AirLogger handlers. And even then, you're still copying messages around. So this is really unacceptable behavior for a logger. I really think that this is not what we want to be doing. So we can do better than this. We can make different choices, and we can do better things. So one of the alternatives that's out there is Riak error, who was written by my colleague Scott. And what it does is it replaces AirLogger handlers with a custom AirLogger handler that will truncate large input rather than try to print it all. So that's a step forward, but one of the problems is it uses debug flat size to figure out how big the term it's going to be printing is. And the problem with that is if you debug flat size on a 64 megabyte binary, it tells you that the binary is like 8 bytes long. You're like, oh, wait, that's the size of the reference, not the size of the binary. So you can crash Riak error with large binaries because it doesn't realize that those are large binaries. And when it detects it's in like big term mode, it sort of falls back to this really clumsy format that it does. So the message becomes really hard to read. And there's still no solution for your mailbox getting enormous or giant terms being put in your mailbox. So, a little bit before this came out, I had actually been doing into this problem independently, working on call centers for a company in upstate New York. And the Erlang call center I wrote had this same problem. We were out of memory in production with, gen servers with lots of stuff in their state crashing. So I wrote something called CPXLog, which was built around an async gen event. It installed an AirLogger handler to take messages out of AirLogger and put them into CPXLog. And I actually ended up writing a tokenizer for the IO format string format, so I could integrate trunk IO and format strings and print and truncate at the same time. It was really kind of crazy, but it did work. And you could actually have multiple log files, each with different levels that were being consumed, different log levels. So you could have a log with only errors and a log with only info messages in it, that kind of thing. Oh, and I forgot to mention AirLogger only lets you have one log file open at a time. You can't log separately at all. So some more stuff that CPXLog could do. It could, you could change what levels you wanted to see at runtime. It also had a syslog backend, which I actually wrote a port driver to do. And you could actually say, I want to look at debug messages for this particular module. So your system's running at the info level, but I want to debug module foo. I could see the messages. In addition, I could see the messages for module foo, which was handy for debugging. But it was under a pretty obnoxious license, the CPAL, which I won't get into how much I don't like that license, but it wasn't my choice. And then I ended up changing jobs, and I went to write jQuery for a year. And I won't get into how much I hate JavaScript either. So then I got hired at Basho. I was back to doing Erlang again. And shortly after I was hired, it was actually at the Erlang factory 2 years ago. A bunch of the support team were there. And they were complaining about how much they hated Erlang logging. So I showed them the CPXLog stuff I had done. And then they sort of pestered the VP of engineering until he said, yes, please write us a new logging library because the one we have is, we were using Riak, Basho was using Riak Error at the time, but it still wasn't where people wanted it to be. So at that point, Logger was, sort of conceived and building it began. So I did a lot of reading on both, Riak Error and all the other alternatives at the time, and I sort of tried to learn the lessons of history to sort of, try to move the bar up a little bit and do logging better than had been done before. So Logger has some philosophies that maybe the other loggers don't share. For example, logging should never ever crash your node. It should not happen. It's ridiculous. You should never crash a node because you're trying to log something. It's insane. Logs should be customer readable. We shouldn't dump, a 40-line tuple to the log and have the customer panic because it looks like some scary, ridiculous thing when really some ephemeral process crashed with some trivial error. But it makes people panic. They see that and it's like, I don't even know what's going on. Is my VM core dumping or what is this? I can't read this. It's just curly braces and yeah, bad. Rotation should be easy. You should be able to rotate logs just like you do with Apache or anything else. It should just work. You don't have to think about, catting, hex dumping index files and all that ridiculous nonsense. It should just work. And you should be able to, have lots of log levels and be able to pick what you want to see at runtime. If I want to see the warning messages, if I only want to see error messages, whatever. It should be up to you what you want to see. And you should be able to change your mind. So, this is sort of the not invented here syndrome. But I did actually consider working on one of the existing ones. But I found that a lot of them didn't really share my philosophy of how I think logging should work. So I decided that, I was going to become a celebrity and write yet another logging library for Erlang, because everybody else who does it is a big celebrity. So what does Logger have? It actually has a forked trunk.io, and trunk.io is a library that you use to say, I want to print this term, but I only want to print 47 bytes of this term. And even if the binary is 2 gigabytes long, it will only print the 47 bytes, and it won't use up tons of memory trying to do it. IOLib is actually from OTP. It's the thing that gets called when you call IO format. So I sort of took both of those, I heavily modified them, and I made the IOLib fork use trunk.io so that you can do like an IO format with format args, format string arguments, and a limit on how big the resulting output should be. And then I quick checked the hell out of it to make sure I got it right. I actually found a couple bugs in IOLib from OTP, interestingly enough, that I think one of them is fixed in R16 now. So, but it's pretty solid, it's pretty fast, and I have a boatload of tests for it. So it works pretty good. It's actually a pretty handy little thing by itself. I may split it out of Logger at some point. Another thing that Logger does is it installs an AirLogger handler, and it sits there and it watches for common OTP errors, like gen event crash, gen FSM crash, supervisor doing something, gen server crashing. It spots those, and it rewrites them from giant tuple of doom into something that people can read without knowing Erlang. It has the 7 syslog levels. A bunch of them, people don't tend to use the higher ones because it sort of gets a bit melodramatic because you have like 5 really dangerous sounding names, but they're there if you need them. And one unusual thing that no other Erlang logging library uses is that the calls to logging are done. You do like logger info, but it's really a parse transform. And what the parse transform does is it captures a bunch of call site information for you, module file, module function line. You can't actually get function with a macro, interestingly enough, but you can with Erlang and get line. You can get current node. You can get the PID. You get a couple other, as much as we can grab sanely already for you. It also it also wraps the call in some magic to say, if you're not consuming debug messages, we're going to short circuit out of that. So you don't even have to do all the collection of the data. So it's nice to have the flexibility of the parse transform. What else does it do? Has the ability to route log messages to custom destinations based on the metadata. It supports both internal size and date rotation. I stole the date specification stuff from new syslog from FreeBSD. It supports external rotation. You can move and delete you can move or delete loggers, log files at any time, and it'll notice and it will reopen the file and keep going. It supports the file, console, and syslog backends. The syslog backend is a separate repo, but it's supported. And there's a ton of ones from the community: SMTP, AMQP, Logly, and then ones that I thought were a troll originally, but they turned out not to be: the CouchDB and MongoDB backends. I thought I was being trolled, but not. So here's an example of what you would get before, and then what Logger rewrites it into. So gen server crash terminated with reason, no match of right-hand value, empty tuple in the crash module in the function handle call with the arity of 3 on line 55, as opposed to this, which I don't care about a lot of this, and it tells me yeah, I think this is better. You may disagree, but I think this is better. And then we have a quick tracing example. If I want to get all the debug messages for the flux capacitor module and send them to the console, I just do logger trace console and tell it the module and tell it the debug level. Same thing, I can trace to a brand new file. If I want to debug that module to a file, I do the same sort of thing. You can actually specify multiple things in that prop list if you want to trace on module and function, or module and PID, or module and node, or any of the metadata. You can actually supply custom metadata, so you can do things like put request IDs in the metadata and then be like, I want request ID 17 to go to this log file if I want to debug request ID 17. And you can actually trace to existing log files too. You can send messages. You can extend what that log file is writing by pointing traces at it. So we're sort of going to have a Erlang logging library shootout now. And the contenders here are AirLogger, the reigning champion. Log for Erl, which is inspired by Log4j, which I guess is some Java logging library. I don't know. I don't know anything about Java, so I guess it's big, cool, I don't know. AirLogger, which was written for the first SpawnFest, was actually written concurrently with Logger, but they didn't announce it and I didn't announce it. And we both released it almost at the same time. We're like, oh, that's kind of weird, but whatever. Sort of a weird duplication of effort, but oh well. And then we have Elog from the Inaka people, or I don't know, Inaka, I don't know how to say that. And then ELogger from Bluetail, which is like a blast from the past, somebody pulled it out of Jungle and like resurrected it. So I was like, well, it's there, I might as well try it. And then FastLog by opscode. There were actually a lot more candidates out there, but I sort of ignored the ones that hadn't done a commit in 2 years or more. So those were the ones that seemed like relatively credible. So we're going to quickly cover these. I guess we still got time. Yeah, we're doing okay. Although we're behind, whatever. So log4Erl is a synchronous gen event. It has an AirLogger handler that redirects into log4Erl. It uses the sort of log4j appender formatter design. You know, lots of verbosity, lots of modules that seem unnecessary. It has lots of backends: console file, SMTP, XML, syslog, you know, some more. It has 5 log levels, not syslog 7. I think it, you know, decided it didn't need quite as many hysterical log levels. And you can change them on the fly by recompiling a module, and it will, you know, it recompiles a function in a module that will then accept or deny messages based on the log level. It's kind of neat. AirLogger is an asynchronous gen server, which is quite an unusual choice. And basically, the gen server has handler modules installed. It also has an AirLogger handler. So again, AirLogger messages can go into AirLogger. It has file, console, syslog, and scribe backends. The handler modules aren't either asynchronous or synchronous. It's sort of up to the handler module. So the file module, by example, is asynchronous, but the console one is synchronous. That's fine. It has something called flows, which are very similar to loggers traces. I actually stole the idea from AirLogger because I liked it. So that's where it came from. It's not identical, but I sort of stole the concept. And it also will recompile itself when you change the configuration. FastLog. It's an asynchronous gen server. No AirLogger provided for this one. It will only write to a synchronous disk log. That's all it does. One nice thing it does do that, to its credit, is the only one that does this, is it has overload protection. If the gen event mailbox is larger than 5,000 messages, it will not send to the mailbox to try to help with overload conditions. There's 0 documentation, but I was able to read the code and figure it out, so it was pretty straightforward to get working. Elog. This one's really kind of strange. It has a registered process per log level. All the logging is asynchronous, and I couldn't really figure out how it worked. It has a backend per log level, but also a default one, and I was sort of struggling with this. I managed to finally figure out the magic to get it configured, but it wasn't clear, so I may have screwed this one up. I don't know. If somebody knows how to use this thing, you know, you can send me a patch on how to use it right, because I sort of did the best I could. Oddly, also, it uses Riak error, but it doesn't use Riak error to truncate large input. It just uses it to test if it's like a SASL message. So I was a little confused at that, but OK, whatever. ELogger, the blast from the past. It uses a dislog backend for AirLogger. It doesn't have an actual logger. It is purely a backend for existing AirLogger. It uses some undocumented disk log APIs that are apparently they wrote just for it. I don't know. It synchronizes the disk log per message. And it's not a real OTP application. This one was really infuriating. It will read its config from the current application. It's not like, you know, application get env SASL key. It reads it out of the current application. So trying to benchmark this thing when you don't have a current application is a frickin' nightmare. I had to do all sorts of horrible hacks to pretend I had a real application. I think I put the keys in the kernel config and like changed the group leader to be the kernel group leader so that the app config, awful, awful. Don't do that. Terrible. So there's a repo on GitHub called Vlogbench under my personal account. It's a benchmark. It's a framework for benchmarking log libraries. So it supports all the ones I just covered, including a fork of AirLogger that uses synchronous notification rather than asynchronous notification. And it has a few different sizes of messages it can generate. So there's like simple, small, large, huge, and enormous. But huge and enormous are so bad that we're not actually going to cover them because it would just take days to run the benchmark. The number of workers is configurable, so you can say I want one process to log as fast as it can, or I want 4 processes to log as fast as it can. There's no rate limiting right now. This is purely a benchmark of how fast can we log messages. All right, so each benchmark for each library has 3 phases: the setup, the run phase, and the finish phase. The finish phase is basically to ensure that the logging library actually did what it said it did. Make sure that it's actually processed everything and done everything. So we don't, if you just fire everything into a mailbox in another process and say, I'm done, you're sort of cheating because you haven't actually done the logging. You've just sort of passed it off to somebody else. So there's a little bit of checking that's done to make sure that you actually do what you say you're doing. Results are in operations per second. I just take the number of, I just divide one by the other and get how many log messages we wrote per second. It includes the time for finishing. And for each benchmark, I did 3 runs, and I selected the median value. So I had to disable the FastLog large mailbox check because it was kicking ass in the benchmark, and I couldn't figure out why. And I was like, oh wait, it's not logging half of the messages because it's throwing them away because the mailbox is too large. So I had to turn that off, and poor FastLog went from being the fastest logging library not to being so fast. So I feel bad. They did a good job with that. That's a good choice to make if you don't care about dropping log messages. If you do, not so good. And to be fair, none of the other ones do it, so I felt in the interest of fairness, I would turn that off. AirLogger is interesting because it's asynchronous, like all the way down. So the finish step will actually call dislog sync to make sure that we actually sync the dislog and don't sort of cheat by having a ton of crap in the buffer. So, So here's the first benchmark. You can see that AirLogger dominates. It's the purple one, if you can't see the legend. We'll go over them in number. So we start, they're all being the same order all the time. So this is regular AirLogger. This is the synchronous AirLogger, which you can see the penalty of async versus synchronous, because asynchronous is a hell of a lot faster. This is Elog, this is ELogger, this is AirLogger, this is FastLog, this is log for Earl, and this is my personal favorite logger, which is not the fastest. It's tied right now with the synchronous error. Actually, it's behind the synchronous AirLogger. It's the 4th fastest. So, why would, that's not great. Here's some slightly larger messages, and it's about the same. Nothing really changes. The overall throughput goes down, but, Logger caught up a little bit to the synchronous AirLogger, but that's about it. So AirLogger is really fast because it's got a completely asynchronous pipeline, which has its ups and its downs. Getting large mailboxes are bad, though. Compare AirLogger to the synchronous AirLogger, and you can see that the VM will actually penalize you if you send a message to a process with a large mailbox. You get descheduled if you do that. So I suspect why that penalty is there is that when the mailbox gets enormous, that poor worker is getting descheduled constantly because all it's doing is sending messages to AirLogger. And the reason Logger is slow is it's always checking for rotation. All the time. Every time you write a message, it checks that you didn't rotate the file out from under it. So that comes at a price. And ELogger constantly syncing the disk is really expensive. And I don't know why Elog is doing what it does. I don't know. Elog is just an enigma to me. I don't understand it. So this is with 10,000 large messages. One worker is writing. I forgot to mention the last benchmarks were 10,000 messages, one worker. So now the field has been a little bit changed here. The overall throughput is much lower. We're only at about 400 operations a second here. But the only one doing more, the only 2 doing more than 100 messages a second are strangely ELogger and Logger. All the other ones are literally doing tens of messages a second, which is pathetic. But that's what they're doing, so when that happens on your node, you are in trouble. So, and that message was only 80 kilobytes. It was an 80 kilobyte binary. That's all it was. And that caused that level of collapse on all those logging libraries. The only reason ELogger survives is it has a check for large binaries, and it truncates the large binary. It's the only reason it manages to survive. If you use a string, it gets really bad because you avoid the large heap, because you're not passing a reference to a binary anymore, you're passing the actual string. And ELogger can't survive it. The only one, like Logger is the only one that, I think the others even, a bunch of them out of memory on that test. Logger's the only one that can handle it. So now we're going to try with for workers. With for workers, AirLogger just goes through the frickin' roof. I mean, it really pushes those log files. And you know, that's good. Actually, Logger is now #2 somehow. I don't know why, but I guess it's a little more parallel than the others. It does the format in the calling process. A lot of them pass the format string and arguments to the logging process, and so you lose parallel operations there. So maybe that's why. Pretty much the same graph with the small size rather than the simple size. Yeah, AirLogger is very parallel, very asynchronous, so it wins big. But now, with the large file and for workers, you know, Logger does 4 times better than the last test, but both AirLogger and FastLogger out of memory the node. So AirLogger is great until it's not great, and then your node is crashed. ELogger still manages to sort of chug along. It's a little, you know, logger that could, I guess. But it's the only one that's, you know, even a credible competitor, and it's not. AirLogger is interesting. It always logs at about 180 messages a second. No matter what you're doing, it's always 180 messages a second, which I don't know why. I guess it's the synchronous call it does, but it's pretty much constant. But at least it doesn't out of memory. That's better than out of memory, I guess. So yeah, they all, you know, that's basically what I said. They all, you know, logging is hard. So let's talk about Logger 2. I tagged the RC earlier this morning, actually. So what's new? The metadata is now passed into the backend. So the backend can do magical stuff with the Logger metadata. Before, it was just sort of, it was provided a big string and said, this is your formatting, here you go. So now you can actually do things like, you know, have a backend that logs the metadata in a way that you would prefer. The asterisk there is because it's a backwards incompatible change. If you have a custom backend for Logger, you're going to have to rewrite it to support Logger 2.0 because I changed the backend API completely. We switched from Mochi Global to ets to store the log config stuff. So we went from being one of the recompile modules and reload them on the fly kind of applications to just using ets because it actually ended up being faster and I had less awful code to deal with. Because Mochi Global is a scary, scary thing. I also added syslog comparison flags, so you can do stuff like log levels less than info, you know, log levels that aren't warning, you know, read the syslog documentation if you're curious in how those work. They can be handy. They're just sort of, I was just playing around. It has support now for web machine and cowboy error messages. It will rewrite them to be like OTP messages. It'll make pretty versions of them. It only works for Cowboy 0.8 and above. I got a patch into Cowboy to make the error messages consistent so we could catch them in Logger and reformat them. You can actually store, Logger will now capture the application a module belongs to at compilation time, if it can, as well as allow you to store metadata for a process in the process dictionary. So you can, if you have a process that's going to run for a long time, you can cram all the interesting, you know, custom metadata in just a process dictionary key, and every time you log, you don't have to pass that metadata around anymore. It's just part of the, it's captured as part of the parse transform. It also supports printing records with like minimal work. So basically, all you have to do is you have to use logger PR for print record. You give it the record, and you give it the module the record originated in, or where a module that record knows about that was compiled with the logger parse transform. And it will actually print, you know, with the hash and the curly braces and the commas, and you know, it'll print your record in a legible way rather than just giving you a tuple, a tag tuple with 20 fields, and you have to go and sit with the terminal, you know, Vim on the other terminal and feel like, well, the 6th field is this and the 8th field is this. This will actually tell you what field is what, so that's nice. It's more magic in the parse transform. It will notice record definitions and stash them in the application or the module attribute. So as long as you know where the module came from, you can now pretty print it, assuming it was compiled with Logger. So I think that's nice. Console colors. A fellow named Deadzen patched R60 or Erlang to allow to not strip ANSI escape sequences. So that you can now do color in the R16 shell. And then he patched Logger to support it. So you can actually set up a custom. This is just the one he did. But you can actually configure what you want your colors to look like. And if you want to have a pretty shell, now you can. So that's nice. And let's look at the performance of Logger by version. So basically, on the small one-worker test, 10,000 objects, or 10,000 messages, we've more than doubled their performance. It's nice, right? So how did I do that? There was some kind of interesting trickery involved. So I changed how often we check for external rotation to be, instead of every single write, by default now it's a second. You can specify the time in milliseconds, or you can always do it still if you want. But so worst case, you lose a second of messages before rotation kicks in, or it reopens the file. As long as you're not deleting the files, you're just moving them, that's fine. It'll just write to that old file for a second and then open the new one. So it seems like a reasonable compromise. You can set it back to the old way if you're wicked paranoid. I don't know. Also, an interesting trick that I did was to install a custom handler into the Logger gen event that looks at it every time Logger gets an event. It looks at its own mailbox. It doesn't consume the log message. It doesn't care about the log message. It just looks at the mailbox. And depending on the mailbox size, it tells everybody else either to synchronously or asynchronously notify out of messages. It switches between async and sync modes depending on load, so that we can be fast when we're not backed up. But as soon as we start to get backed up, we lock everything down and say, you've got to start being synchronous now, so that we limit the size of the mailbox. So let's do all the charts again, I guess. We'll do it fast this time. So Logger kind of wins a little bit now. The red one is the new Logger, like Logger 2.0. The green one is the old Logger. So the colors are all the same. I just added one more column. So we sort of win there. This is sort of the only case we really win by such a ridiculous margin. I don't know why it's quite so fast in this case, but it is. We still win on the simple size, but not nearly as much. And we win on the large size still. So we still handle large messages without problems. For workers, AirLogger pulls ahead because asynchronous is still going to be faster, and they can still sort of push the trouble down the road more than I can. Same thing. It's not a massive win anymore. So you mean like look at the old green one compared to where we are now. So we're more than twice as fast still. And we win still at the large size. So that's great, but AirLogger is still going to try to kill you. Because you can still get your AirLogger mailbox become enormous when AirLogger decides it's going to storm your node with errors. So this is still a problem. Fred Hebert wrote a really nice little app. Between he and I, we sort of worked on it together, called Cascading Failures, that emulates a failure he was seeing at AdGear, where he had a lot of processes referencing an ETS table, and that ETS table would die, and all those processes would crash, be restarted. The process owning the ETS table would also be restarted. Then the ETS table would crash, owning process would crash again, and all the workers would crash again. So it sort of emulates the sort of cascading failures you can see in production in an Erlang node. So let's look at what AirLogger does versus what Logger does when you run that against the node. So the top one is AirLogger. And the scales are different on this. So you can see that AirLogger tops out at 12 gigabytes, whereas Logger pretty much hovers. It peaks at 700 megabytes, but it sort of hovers in the well below that, sort of 500-600 megabytes in memory. I wrote like a little hacked up ERRD sort of thing to monitor memory on the node, but it's pretty obvious that that is bad, and this is not as bad. So, and this is for 15 minutes. I gave up because I was like, I only have 8 actual gigabytes of RAM on this machine, and I think 12 is excessive to show, it's sufficient to show the problem here. So another thing that Logger 2.0 has is it has a high watermark in the AirLogger handler it installs. If you basically say, I only want to accept X amount of messages per second from AirLogger. And if you get more than that, I'm going to start throwing them away until the next second hits. And I'll log how many I threw away and reset the counter and keep going. So usually what happens is is when you get these sort of error logger storms, they're all the same error over and over and over and over again, because a lot of processes are having the same problem or whatever. So it's better to capture a representative sample and not crash a node if you don't have to. Maybe you'll survive the storm rather than for sure out of memorying the machine. So this is sort of, and it's optional. You can turn it off, you can turn it on, you can do whatever you want, but it lets you at least say, I'm going to try to throw away messages to be able to survive this event. For like if you have a temporary outage, you'll be able to survive it rather than crash the node. So it's still not perfect. You still can't prevent OTP sending giant messages to AirLogger. You can use the format status callback for all of the gen whatever behaviors. It's not very common, but you can tell format status to filter the state that's passed to AirLogger as part of the log message. Another thing you can do is when sending large messages around, if it's going to a process that might crash, or just in general, if you use a binary rather than a list, copying that message around will be a lot cheaper because it'll be an off-heap binary. So that's another thing you can do to sort of prevent these things from happening. So quick wrap up here. Production uses of Logger. It's been in Riak since 1.0. Zotonic now ships with it, I believe. Where Fred used to work, Agir uses it. There's lots more. I don't know who I can tell or I can mention, but I know lots of people seem to be using it now. So it's actually, it's up to the 19th most watched repository on our GitHub, and it's been in development now for almost 2 years, 2 years this summer. So it's mature, I think, or definitely maturing. This graph is a little hard for you guys to read, I think. This is actually from Fred, but it shows what happens when the AirLogger queue spikes up to 12,000 messages. The node just goes away, right? This is like what the green line is good, but the green line, flatlines until the node finally comes back and stuff happens again. It's a production outage, basically. That's what AirLogger provided there. They gave them a free production holiday or whatever. So this is the same sort of graph, but you can see that this is Logger 1.2 or before. So even though the mailbox size is still spiking, it's purple now, but not the same color as last time. Even though the message thing spikes to 20,000 messages, Logger actually survived this, and the system kept going, and they were able to debug it. One of the other problems with AirLogger is that if it crashes, because the mailbox gets too big, you lose all those messages, and a lot of time the actual problem is somewhere hidden in your mailbox, and by just losing absolutely everything, you have no debugging. So they were actually able to figure out what their problem was once they switched to Logger, because they couldn't debug with AirLogger because it would just fry the node. All right, so that's about it. I'd just like to thank a couple people. Steve Vanoski sort of helped me design this originally. We sort of Skyped for a while and bounced a bunch of crazy ideas around, most of which actually ended up happening. It was his idea to do the parse transform, so if you don't like that, I guess you can sort of blame him too. Fred Herbert helped a lot with, telling me about, his production experience with Logger and ideas to make it better. He wrote a cool SimHash deduplication stuff that we played with, but it ended up being so finicky to configure that it was easier just to do the high watermark thing. Everybody at Basho for putting up with my incessant pull requests and for giving me some really interesting ideas, like the record printing was suggested by a couple people at Basho because they got mad because they couldn't read the records in the log files. So I was like, the hell with it, I hacked it in an afternoon. So, and everybody else who's used it, contributed to it, filed a bug, complained. A lot of the improvements have been driven by people not at Basho using it, so I appreciate everybody who gave me feedback. And that's it. I don't know if we have any time for questions, given we're still behind, but.
We're about 9 to 10 minutes behind, but we'll take a couple quick questions.
So I was wondering, as you mentioned about if you're going to do some messages, when the mailbox is completely full, you're assuming that they may be like replicated messages. Have you thought about, the possibility of grouping messages that they are exactly the same, or they are sharing most of the components of the information, and just reading like the original one, and it's repeating like 5 seconds or something like that, just say the
Yes, so it was a question about if you, instead of blindly discarding messages from the mailbox, if you sort of figure out if ones are similar and say, I had the same message 5 times. That's what Fred's dedupe work did. The problem with it was, A, it's expensive, and at that point you can't really afford to do expensive operations, and B, trying to traverse, it's hard to, you really want to get rid of that mailbox as soon as possible when it's, because it will grow very, very quickly at that point. You really, and if you're using Logger, you're using Logger for everything else. The only messages you're getting from OTP are from gen events and gen FSMs and stuff crashing. So usually those messages are very similar, and those are the only ones that are the drop is applied to. All the messages from Logger are not subject to that drop. It's only messages coming into AirLogger. So it's a trade-off. You could lose valuable information there, but on the other hand, it's not very easy to do anything better right now. We played with it a bunch, and this was sort of our compromise for now. Maybe we'll come back to it later, but.